Hello everyone, I'm Kelvin L. Pabie. Welcome back to SM Academy. All thanks to Mr. Prince Alpha for his contribution. Today I'll be discussing strength of material. Gen 201. On a strength of material, we're talking about normal stress. Normal stress. Questions number 1. Thank you. So this is question number 1 on a normal stress. It says a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kN. To determine the outside diameter of the tube if the stress is limited to 120 meganewton per meter square. So let us start with our data. We'll say that the inside diameter or the inner diameter represents small d. Inside diameter is equal to 100 mm. Now the outside diameter represents capital D. Is questions mark. And now the force P or F represents 400 kilonewton. So determine the stress. The stress is limited to, so they give us the stress of the steel. Stress of the steel is limited to 120 meganewton per meter square. So we are told to find the outside diameter. So let us get a diagram of this problem. So this is the steel. It's a hollow steel. This is the steel. We know this is the outer diameter, and this is represent D is equal to 100 millimeter. And this is the outer diameter. Represent capital D, and this is the steel. This is the hollow steel. So looking at this, we know that stress is equal to force over cross-sectional area. Stress is equal to force over cross-sectional area. But note, we are not given the area, but we can generate the area from the diameter, because we know that area is equal to pi d square over 4. But here they give us 2 diameter, so we have to subtract the larger diameter from the smaller diameter. So we say the area is equal to pi d square minus 4 divided by 4 minus pi d square minus 4. So this is the data. We have the inner diameter is given by 100 millimeter. The outer diameter D, with question mark, we have to find it. By the force is equal to 400 kilonewton. By stress is equal to 120 megapascal. We know that stress is equal to force over area. So in order to find the outer diameter, we have to relate it to the area of the diameter. We know the area of the diameter is equal to pi d square divided by 4. But since we having two diameter, we have to subtract the inner diameter from the outer diameter. So we say area is equal to pi outer diameter square minus pi inner diameter square divided by 4. Since pi over 4 is common to them, so factor it out. So we say the area is equal to pi over 4 parenthesis open the outer diameter square minus the inner diameter square. So here we can say the stress is equal to the force over the area. So we make force the subject. So the force is equal to stress times area. So we can substitute the value. We can substitute the area there. So we can say the force is equal to the stress times pi over 4. And then we'll see area now. We'll substitute the value there. Outer diameter square minus inner diameter square. So now we can substitute the value. Now the force is equal to 400 kilonewton. But you know kilo is very simple, 1,000. So say 400 times 1,000. If you go 400,000 Newton is equal to the stress is equal to 120 megapascal. Now pascal for every pascal we have 1 Newton or meter square. So we get 120 times 10 mega is equal to 6 power. 6 power Newton per meter square times pi over 4 outer diameter square minus the inner diameter is 100. So say 100 millimeter all square. 100 millimeter all square. So we say 400,000 Newton is equal to 120 times 10 raised to 6 power Newton per meter square times pi over 4 outer diameter square minus that 100 square. If we give out 10 raised to 4 power, because 100 times 100 is 10 times 10 is 100 times 2. If we give out 10 raised to 4 power millimeter square. Then we can start reducing the problem. Before reducing the problem, we divide both sides by 100 and 20 times 10 raised to 6 power Newton per meter square. Divide that by 120 times 10 raised to 6 power Newton per meter square. So this we cancel this. We know that we also having 400. 1, 2, 3, 4, 5. Writing standard notation. So we get 4 times 10 raised to the 5th power Newton. This is Newton. Divided by 120 times 10 raised to 6 power Newton per meter square equal to pi over 4 parenthesis open outer diameter square minus 10 raised to the 4 power millimeter square. So now if we drop the power down, we subtract it by 1, we have 4 Newton divided by 120 times 10, we have 1,200. 1,200 Newton per meter square is equal to, what we say, pi divided by 4. We use our calculator, we know pi is 3.14 bar. Let us put the entire pi there. So press shift, we press pi, press divide by 4. You get 0.785. So you get 0.785 parenthesis open outer diameter square minus 10 raised to the 4 power millimeter square. Millimeter square. So we say that 4, we can say 4 divided by 1,200. We know that Newton, you get 3.3 times 10 raised to the minus third power meter square is equal to 0.785 parentheses open other diameter square minus 10 raised to the full power millimeter square. So we divide both sides by 0. We're going to divide both sides by 0. 0.785 divided by 0.785. So I'll cancel this side. So we get 3.3 ESP minus 3 divided by 0.785. We get 4.2. We have 4.2 times 10 raised to minus 10 power meter square is equal to other diameter square minus 10 raised to the full power millimeter square. Divide this meter square to millimeter square so that we'll be having a left term to add or subtract, depends on the sign. So now 1 meter is equal to 1000 is equal to 10 raised to 10 power millimeter. So now 1 meter square is equal to 10 raised to 10 power millimeter all square. So 1 meter square will be equal to 10 raised to 3 times 2 raised to 6 power millimeter square. So now 1 meter square will be equal to 10 raised to 6 power millimeter square. So again, raised to already know the pattern there. So now I will say 4.2 times 10 raised to the minus 10 power meter square times, we want to convert it to millimeter. We know that 1 meter square equal to 10 raised to 6 power is equal to 10 raised to 6 power millimeter all square is equal to the other diameter square minus 10 raised to the full power millimeter square. So in a meter square, we cancel meter square. So we have 4.2 parentheses open 10 raised to the minus 10 power times 10 raised to the 6 power, it closes millimeter square because 10 raised to the bases are the same. So we get d square is minus 10 raised to the full power millimeter all square. So since the bases are the same, we take one, we add the power. So we get 4.2 parentheses open 10 raised to the minus 3 plus 6, it will give you what? 10 raised to the 10 power millimeter square is equal to the other diameter square minus 10 raised to the full power millimeter all square. So multiply 4.2 times 10 raised to the 10 power. We will have 4.2 ESP just a 10 power. We have 4,200 millimeter square is equal to 10 is equal to d square 10 raised to the 4 power equal to 10,000 millimeter square. So we send it across. We have 4,200 millimeter square plus 10,000 millimeter square is equal to diameter square. So we have 4,200 plus 10,000. That's equal to 14,200. 14,200 millimeter square. Call it d square. But we want the diameter. So the square on both sides. So to take square root this, okay, give us 119. So we get D is equal to 119.2 millimeter. So the other diameter now becomes 119.2 millimeter. Thanks for watching. Don't forget to subscribe, share, and like. Thank you.